More on function families. First off, what is the domain of the function b of x equals the square root of 2x minus 8? Well, with square root functions, you're limited on what numbers you can plug in for x. That's what domain is what x values you can plug in. And so square root functions, we take whatever's inside the radical, whatever's under the radical symbol, and set it greater than or equal to 0 and solve for x. So that means we take 2x minus 8 greater than or equal to 0. Now solve. So we add 8 to both sides. Gives us 2x is greater than or equal to 8. Divide both sides by 2. That gets us x is greater than or equal to 4. That means the domain of b of x is x has to be greater than or equal to 4. Another one, what is the domain of f of x equals square root of x plus 3? Same thing. Take what's under the radical, set it greater than or equal to 0, and solve. So minus 3 from both sides, and we get x has to be greater than or equal to negative 3. That is the domain of f of x. Now, what do square root functions look like? Well, the square root is the inverse operation of squaring something. And we remember squaring, an x squared, is a quadratic. So that's that u that opens up or opens down. When we do the inverse, remember from function families notes, we take that function and reflect it across the line y equals x, and we just switch all the x and y values. But when we do a square root, we're limited to the positive square root. So when we look at that one, we do the positive square root. So on the first one, square root of 2x, square root of the quantity 2x minus 8, we know we can plug in 4. And so I've got that right. Oh, I wish I had my laser pointer on this one, but we've got 4. If I plug it into the function, 2 times 4 is 8. 8 minus 8 is 0, square root of 0 is 0. And so we got that first point at 4, 0. Plug in 6. 2 times 6 is 12. 12 minus 8 is 4. Square root of 4 is 2. That's where we get the second point. The third one, I did a little bit different. I did 8.5, because if I take 8.5 times 2, well, 8 times 2 is 16. Half of 2 is 1, so that's 17. 17 minus 8 is 9. Square root of 9 is 3. So to get the odd roots, so 1, 3, 5, I have to plug in a 0.5 function, or a 0.5x value. So that's why you don't see the 1. But we have 2, 3, and then to get 4 for the y value, 2 times 12 is 24. 24 minus 8 is 16. Square root of 16 is 4. And then on the other one, and notice, take a look at where it starts. Since the domain, the smallest x value I can plug it in is 4, that means the first y value has to be 0, and I have to start at that point. For the second one, square root of x plus 3, negative 3 is the first x value I can plug in, and that gets us a y value of 0. The next one I can plug in is negative 2, because negative 2 plus 3 is 1, and I can take the square root of 1, which is 1. The next one that number I can plug in is I want to take the square root of 4 because I'm looking for the perfect squares. So that would be 1, or well, 0, 1, 4, 9, 16, 25. Those would be all the perfect squares because I can take the square root of them and get a nice number. Excuse me. So the next one, I've done 0, I've done 1, so I want to get a square root of a number is 2. So what do I take the square root of to get 2? 4. So how do I get 4 from x plus 3? Well, I plug in a 1 for x. 1 plus 3 is 4. The square root of that is 2, and I get the 0.12. The next one I would want to get 9. 6 plus 3 is 9. Square root of 9 is 3. Now, graphing absolute value functions. So we have the graph of y equals absolute value of x. We want to know what is the solution if x equals negative 7. Well, you can just plug that into the function. What is the absolute value of negative 7? Well, that's 7, but you can also just look at the graph. When I plug in negative 7 on the x, that gets us up at positive 7 on the y. So y equals 7 would be the answer. Another one, looking at what's the range of the function f of x equals absolute value of x plus 2. Well, that plus 2 on the end, if you remember from function families, transforms the absolute value function, moves it up 2 units. So we look at that, and what is the lowest, range is y value. What's the lowest y value on this graph? Well, it's 2. And so that means, and does the graph go above 2 or below 2? It goes above 2, so that means the range is going to be y greater than or equal to 2. Vertex, what is the vertex of the function? Well, first off, we can take a look at the function that we've got to begin with, that f of x equals absolute value of x plus 2. Its vertex is at 0, 2. And kind of look at the function that we've got going on here. Do we have anything plus or minus inside that absolute value? No. And that coincides with the 0 for the x. So what do we have inside this function? We have x minus 4. That means the function shifts to the right 4 units. And then outside, that shifted it up 2 units, so this shifts it up 3 units. So if we look at the graph, right 4 up 3 is our vertex. That means our vertex is the point 4, 3. Piecewise functions, these are a little bit harder functions that we've got going on. But all it is it takes and breaks up, it breaks up the x-axis into pieces of different functions. So when I look at this, right here on the x values is where we change functions. On the left, we have this quadratic to the left of 3, and to the right we have this linear function. So what we do is we kind of take a look at those answer choices. Which one has a quadratic for the x less than or equal to 3? Well, that first one, y equals 2x plus 5, that's a linear function for x less than or equal to 3. So A's out. And the other one that has that is D. That's also a linear for x less than or equal to 3. So that leaves us with B or C. Now, kind of take a look at the vertex of that quadratic. Vertex of the quadratic is at 1, 1. When I look at C, its vertex is at negative 1, 1. So that leaves us with the answer has to be B. Now notice how I walked through that one. It's just take the function, take the graph, and split it into pieces, and only look at the pieces to come up with which of these sets of equations fits it best. Graphing one, you're probably going to be given a bunch of graphs to pick from, but we break it up the same way. So that top function is an x squared, and that's for negative infinity, less than x, less than or equal to 2. So that means we follow the x squared for all the 2's from 2 left. So I just did a table here. The highest x value I plugged in is 2. And then I went left, so 2, 1, 0, negative 1, negative 2, negative 3. And then I just plugged it into the function. I squared all of those x values. So 2 squared is 4, 1 squared is 1, 0 squared is 0, negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. Remember, when you square, you're taking the number times itself. So a negative times a negative is going to be a positive. And then I plot those. So notice those points kind of go in a little parabola or quadratic shape. Now we follow the second equation, the linear equation, negative 2x plus 8, and the first number I plug in is 2, and then I go to the right, so 2, 3, 4, 5. So plug in 2, 2 times negative 2 is negative 4, plus 8 is 4, negative 2 times 3 is negative 6, plus 8 is 2, negative 2 times 4 is negative 8, plus 8 is 0, negative 2 times 5 is negative 10. Negative 10 plus 8 is negative 2. We plot those points, and then we draw a curve through it. So I would be looking for something like this as the graph that I pick. Last couple are working with step functions, which are a special class of piecewise functions. So Jalen is training for a race. He takes 2 weeks off and then increases his distance 1 mile every 2 weeks. So 2 weeks off is important. That means for the time of 2 weeks, he runs 0 miles, or she, it is a he because it says his distance. Jalen then increases his distance 1 mile every 2 weeks. So look at this first one, and looking across the bottom, first 2 weeks he should be at 0. Looking at the graph for the first quarter of a week, because if we look at the table, each vertical line, well, each x value across the bottom is 0.25. For the first quarter of a week, he's running a mile, and then increases a mile every quarter of a week. So that one's out. Second one, for the first week, he's running 9 miles, not 0 miles. And then he's dropping a mile each week. So that doesn't work. The third one, for the first 2 weeks, well, for the first week, he's running a mile. He took 2 weeks off, and then every week after that, he's increasing a mile. So that doesn't work. Third one, ooh, hey, look at this. For 0 to 2 on the x-axis, and yeah, you probably hear thunder. We got a thunderstorm rolling through. For 0 to 2, he's at 0 miles. That fits. And then at the end of that 2 weeks, what does he do? He increases it a mile and then keeps increasing it every 2 weeks. That's the answer we're looking for. Now, the last one, total cost for a taxi ride includes an initial fee of $2.50 plus an additional charge of $1.50 for each mile or part of a mile driven. Which of the following graphs represents the total cost in dollars Y for a taxi ride of X miles? Well, first off, initial fee of $2.50. You get in the cab, you got to pay $2.50. And then if you go a partial of a mile, you have to pay $1.50. It's not a portion of $1.50 for each portion of a mile. It's a total of $1.50. Okay. So the middle two, this problem's not continuous, so that means it's not linear like this. It's more the step functions. Okay. Now we've got $2.50, and as soon as I sat in the cab, I have to pay $2.50, and then I got to pay $1.50 as soon as that cab starts driving away. So that means for 0 to first mile, I have $4 that I have to pay. Which of these graphs starts at $4? The one on the left or the one on the right? The one on the left starts at $2.50, so it's not that one. The one on the right starts at $4. That would be our answer.